All right, welcome back. I'd like to look at page 2, which happens to be problems 4 and 5, but problem 5 is a pretty big question. So we'll see if we can get through all that in one. So here we go. Start with question number 4. And let's just say that this is a situation that we were handed where someone gave me this problem and they said that we were going to find the roots. And one of our friends went in there, a student went through and found these roots. And I wanted to know a couple of arguments that would shoot this one down. And so remember, one of the things that we should know is that when we look at our rational roots there, remember, these are the numbers that are the numerators. So my numerators are 1, 2, 3, 4, 6, 8, 12, and 24. I think I got all of them there. Now, it's possible I missed one. And my denominators were 1, 2, 3, and 6. Now, keep in mind, if that's the case, then the number 2 is there. I could have 2 over 1. The number 3/2 is there because I have that one, but 3/4 is not in the rational roots. So I could say, no, 3/4 is not a possible rational root. Okay, that's number 1. 3/4 is not in the list because the number 4 is not a factor of 6. That's the first reason why. Now, it does say several. I left that a little bit open-ended. Here's the second thing that I know is that if I looked at Descartes' rule of signs, Descartes' rule of signs quite specifically says there's 1, 2 sign changes. And if there are 2 sign changes, that means there should be 2 or no positive real roots. And if you look at this problem, this would directly violate that because this student is saying that there's precisely 1 positive real root, and that's not possible. There's either none of them at all, or there has to be 2 of them according to Descartes' rule of signs. Another reason would be that if you looked at f of negative x, remember we looked at this if we wanted to look at it the other way. If you replaced x with negative x, I get negative 6x cubed minus 13x squared plus 10x plus 24. Again, just replacing x with negative x, what I see is 1 sign change. Therefore, Descartes' rule of signs would say 1 negative real root. And that is not what we see here. We have a proposal of 2 negative real roots as opposed to 1 negative real root. So that's 3 distinct different reasons for different, these are kind of overlapping conceptually, but that's what I had. Okay, now, so when we go through this, the first thing is the nature of the roots. This is, again, Descartes' rule of signs. We could see 1 sign change and another one here. So that would be 2 or none in terms of the possible positive real roots. Now, those could be nice numbers like 2/5 or like, let's see, like 7/3, something like that would be a possibility. But it also could be something like, 1 plus the square root of 3 over 2, or some irrational number that's not so pleasant. Now, when we go into the next one and we looked at t of negative x, I'd have a negative 5 times, a negative 4 times, a negative 3 times, and another negative. Here, 2 negatives and a third negative, and 2 negatives, and that. So I got 1, 2, 3. So this would be 3 or 1 negative real root. So again, all I'm doing is counting the number of sign changes. So keep in mind, if you replaced x with a negative x, you'd have 5 negatives being multiplied by a positive 12. So that would be 5 negatives. So that's a negative number. Now, in terms of my possible rational roots, this is a place where, just for the sake of brevity, I'm going to go ahead and write this quickly. And so I understand there's many, many, many fractions that could be made out of what I'm writing down right here. But when we look at this, this is a pretty long, exhaustive list with numbers like 1/2, a third, a fourth, a sixth, a 12th, 3/2, 3/4, 3/6, which is really 1/2, 3/12, which is really a quarter. There's like lots and lots of them there, but I didn't want the video to get too long. So I put it there mainly so that when we got to the bottom portion of this question, we could actually make a little bit of reference. So we're going to use this chart to try to make some determinations. And let me move the camera a little bit so that I can see these bottom pieces. So hopefully that's going to work. Trying to get this to fit in the screen better. Okay, so my lower bound is that I want to look for a set of numbers that alternate signs. So plus, minus, minus, nope, plus, minus, plus, minus, plus, minus. So right here, I see, we didn't see an alternation at -4, but we did see an alternation at -5. So the largest lower bound that we have is at -5, meaning I don't need any of those numbers. And the upper bound is the one that goes all positives. And you'll see that at 6, they're all positive, as is true with 4, as is with 5 and 4. But that fails at 3. So the number 4 is my upper bound. So all of my roots are going to be somewhere between -5 and +4. So I'm not going to bother to look at numbers like -7 or 6 or +5 or 6. Now, what I can do too is by the intermediate value theorem, this is what we're talking about, is that 0 is an intermediate value or an in-between value, if you will, between any positive and any negative number. So what I see is right here, there is a root between -3 and -2. I also see another one here somewhere between 0 and 1. And last but not least, I see another one here between 3 and 4. Now, as it turns out, if we were to just maybe cheat just a little teeny bit, what we would see is that there is a little bit of a bounce in the graph at -1.5. Because that's one of the things that I did tell you to do sometimes is just to peek at the graph. Well, that means there's a root somewhere here at -1.5, which is somewhere in here. Now, notice that they're both positive. I got 13 here, I got 24 here, but that could be true if the graph was higher and higher and came down and hit in the middle. That can happen. But the fact that I see that is really, really helpful. So what I decided to do, since I saw that there was a bounce there, is I'm going to go ahead and write out my coefficients. There we go. Now, as it turns out, I'm going to divide by that -3/2. -3/2 times 12 is actually -18. Add down, I get -2. Multiply those out, you get 3. Add down, you get -130. Multiply -3/2 times -130, you get 195. And we add down, we get -122. Oops, I put an extra 2 on that, didn't I? Now, if we took -3/2 times -122, you get 183, which gives me 42. And this times 42 is -63. And magic just happens. It just confirms what we already knew was going to happen. And by the way, 3/2, I never mentioned that, was a possible rational root from what we did here. But because it looked like a nice little bounce, we can divide it again. So if we divided it, again, we drop the 12. Let's see, 3, that's 36. Divided by 2 is 18. And that should be a negative, so I got -20. This times this would be 60 over 2, which is 30. Get 100. 3 times 100 is 300 divided by 2. 300 divided by 2 is 150. I got 28. That's 42, but negative. There you go. Now, keep in mind, we had a 5th degree problem, right? And we've already divided 2 out. So this is a cubic. So this is the constant, the x squared, and the x cubed. But keep in mind, this is one of those things that I've been trying to stress with you guys, is that's the linear factors that we had. And so we have a coefficient of 2 that we did twice. So what I'm going to do is I'm going to divide out that 2, and then I'm going to divide out the 2 again, because I'm going to divide out 2 for each of these coefficients, since we're not supposed to have coefficients other than 1. So if I divide by 2 twice, it's like dividing by 4. So this is now going to be a 3, a -5, a -25, and a 7. Now, the last little thing that I would say is I looked through this list and I was looking for something that was between -2 and -3. And so for me, looking for that value that was between -2 and -3, the only factor in here that I could find that was between -2 and -3 was right here, 7/3. It was -2 and 1/3. So what I decided to do is I decided to take 7/3 negative and divide it in this last little piece. I really wish I had more room, but okay. I got 3 here. And by the way, if that's true, we're going to have 3x plus 7. So when I'm all done, I'm going to take these last pieces and I'm going to divide them by 3 because we have a coefficient. So that's going to give me -7. Then when I do that again, this times this is going to be 84/3, which is see, it should be 28. I get 3, and that gives me -7. And so what is left is 1, -4, 1, because I get to divide, and that's my irreducible quadratic factor. And so what I was asked to do is put it into factored form. It never said find all of the roots or anything. It says write it in factored form. So this is my product of linear, 1, 2, 3, 4, 5, linear and irreducible quadratic factors. And so this is what T of X would look like in a fully factored form. Now, this last one, I think we could get it and we would find those other answers that we have not yet seen, but it turns out to be not all that difficult regardless. So that will end it for this particular video, and I hope that that was helpful, and I will see you back in class. All right, bye-bye.